Here we are at 3.2, the remainder theorem. I'm going to take you back a little bit down nostalgia lane here, and we're going to be talking about long division. So just before we get into all this other stuff, maybe off in the corner here, let's just say if we were to do this long division style, if I gave you a problem, how many times does 12 go into 327? So that's divide 327 by 12. So remember how we did this. Well, we'd say, well, 12 doesn't go into 3, but 12 does go into 32 two times. So put a 2 over there, and that would be 12 times 2 is 24. So now I subtract 32 minus 24, and I get an 8. I carry down that 7, and now I have an 87. Now, how many times does 12 go into 87? Well, if I multiply 12 times 7, I get 84. And that's about as far as I can get. So there would be back in the day of long division. And so when I say, how many times does 12 go into 327? Well, it goes 27 times evenly with a remainder of 3. Remember that here is the remainder. Okay, so let's take a look at our first question. It says divide the following expression. X squared plus 8x plus 15 divided by x plus 3 is equal to, well, we got to figure out how to do that. Well, let's see here. One way we can do this is by using a long division that's very similar to that. Just like how 12 couldn't go into 3, x plus 3 doesn't go nicely into x squared here because there's only one term. Because this is a binomial into a polynomial, I'm going to have to take a look at these first two terms. So I'm going to say, well, x goes into x squared x times, so I'm going to put my x here, and now when I multiply x times x plus 3, I get x squared plus 3x. Okay, so now I want to subtract just like I did before. So now I'm going to be subtracting x squared minus x squared should be nothing. Okay, and just like over here, I didn't put a 0 here. I don't really have to leave anything here. 8x minus a positive 3x gives me 5x. Now I'm going to bring down that 15. I'm going to say, okay, now how many times does x plus 3 go into 5x plus 15? Well, it goes nicely. It goes 5 times. Oop, moving around here. So it goes 5 times. Let's see if I can get rid of that piece. 5 times. And it works out evenly because 5 times x plus 3 is 5x, I don't know what's going on, plus 15, all divided by 0. Okay, so in my example on the left here, I had a remainder of 3, and this one I had a remainder of 0, so it worked out nicely. Okay, so let's remind ourselves what some of these terms mean. So first of all, the dividend, that's the large thing that we started off with. This is the dividend. Okay, the divisor is the binomial in this case. And you'll notice that we're going to use this form of x minus a. So in our example, if we are thinking about x minus a going into this, here we would have an a value in this case if the binomial is in x minus a form, then in this question a was equal to minus 3. Does that make sense? So the opposite of whatever that 3 is our a, and that's a little bit of a foreshadowing that's going to come up in a bit. Okay, so the other piece is here, maybe I'll use this, the quotient. I'll circle with my blue. The quotient is the answer. There is the quotient. All right, and then I guess the last little piece is this is the remainder. Okay, so the quotient is the answer. That's the x plus 5 in this case. The divisor is the, in English sometimes we say the goes into. X plus 3 goes into. And then x squared plus 8x plus 5 is our large polynomial that we started with. So when we're done, we can put this into two terms. Here, in the first way we can do it is we can say the dividend divided by the divisor is equal to the quotient plus the remainder over the divisor. Well, let's try to put that that example here in that form. So our dividend was our big polynomial, so that would be my x squared plus 8x plus 15 divided by the divisor. So my divisor was x plus 3 is equal to, and this is really the way that the question was formed, right? My dividend divided by my divisor is equal to my quotient, which was my answer, x plus 5, right, plus, now we have a remainder of 0, so obviously you don't have to write this last part, but I want to write it in so that we notice it. It's 0 over my divisor, which was x plus 3. Okay, so that's the way you would write it that way. The second way, it's circled because I think the writer of these notes wanted to emphasize this. The second way we could do this, we can say, the other way to write this, and if you look at the three terms, is if we multiply everything by the divisor, so the divisor disappears here, but we get quotient times divisor, and then we just get a remainder there. If we write it in that form, so our dividend, that's what we started with, would be our x squared plus 8x plus 15 would be equal to our divisor, which was our x plus 3. Try this again here. Multiplied by our quotient, which was our x plus 5, plus the remainder, which was 0. Okay, so this is the first way to do it. Okay, and then this would be the second way. Both answers are acceptable. And notice that the textbook will usually put it in this form most often, but they do mention that you can put it in both forms. There is a restriction on the variable that x cannot be equal to -3 since division by 0 is not defined. So what did we divide by? We divided by x plus 3, right? And one of the two rules about math that we can't do is we can't divide by 0. So if we're dividing by x plus 3, we say, well, when is that equal to 0? We can't divide by 0, so x plus 3 can't be equal to 0. So that's another way of saying that x cannot be equal to -3. All right. So later on in this course, when we're writing this out, we would add. So I'll just write this out again. If I said x plus 3, I would say this is equal to x plus 5, with the restriction that x cannot be equal to -3. So this is something that we'll be doing I think it's in our next chapter. But for right now, we can say that x plus 5 is the answer, is the quotient. And if we're asked about a restriction, that's the restriction. You say, well, when would the divisor be equal to 0? And you just solve for 0. To verify, we could multiply it out again. So if you look at this form here, if we wanted to check our answer, we could say, well, let's multiply these two together and then add any remainder that we might have and see if we get our original answer. So if we did FOIL in this case, if we did x plus 3 and we multiplied it times x plus 5 and then added whatever remainder we had, what would we get? Well, we'd get x squared plus 5x plus 3x plus 15 plus 0, which was our remainder there. So we would get x squared plus 8x plus 15. And so that's what we wanted, right? So we showed that this is in fact equal to that if we multiply it out again. Okay, so let's try it out. Let's do an example where we divide. We'll say, how many times is x minus 1? Well, we're not going to just use the first term. We're going to use the first two terms because this is a binomial. There's two terms here, so we're going to look at the first two terms. How many times does x go into x squared? No, how many times does x go into x cubed? And the answer would be x squared times. And I'm going to put my x squared here because I want to have room for these two terms. Now, when I multiply this back, I'll say x squared times x is x cubed. X squared times my minus 1 is a minus x squared. Now I have to be careful. It's a little bit different than in my regular, grade school long division, because that when they're just regular numbers, they're always positive. So x cubed minus x cubed, obviously cancels it out. But now I'm subtracting this. I've got minus 2 of these x squares, and I'm subtracting a minus x squared. So I'm actually adding here when I'm subtracting a negative. So this value will go, to the right on the number line 1. So instead of negative 2, it's going to be just a negative x squared. So you got to be a little bit careful about that. There's different ways. Some people might want to put parentheses around there and put a minus just to remind themselves, or whatever works for you. Just remember that we're going minus 2x squared minus a negative x squared. So we're taking away a negative, so we're actually adding. So it looks simple, but you gotta pay attention. You gotta pay attention to those positives and negatives. Now we bring down our 6x. And I say, how many times does x squared go into a negative x squared? Well, it goes into it negative 1 times. So I get negative x squared plus 1. So I'm multiplying my negative 1 multiplied by my x minus 1, and then this is what I get. Now when I'm subtracting, these again will cancel each other out. Oh, did I do this right? Negative. Here. Oops, I did make a mistake. This should be not negative 1, but negative x squared. Or negative x, pardon me. So negative x times x is negative x squared. Negative x times negative 1 is positive 1x. Positive x. Okay, now I'm ready to start subtracting. So these are going to cancel each other out. 6x, take away a positive x, will give me 5x. Now I bring down my minus 12. Okay, my last step here, I'm going to say, how many times does x minus 1 go into 5x minus 12? Specifically, I'm just looking at the x and the 5x. I'm going to say plus 5 times. So now I get 5x minus 5. And now when I subtract it out, my 5x's are going to cancel each other out. And I will get nothing there, and I'll get minus 12 minus 5 is minus 17. Alright, so I'm done. That's my remainder. And I got my quotient up top. Here it says, what is the restriction on the variable? Well, if I'm dividing by x minus 1, that means that x cannot be equal to 1. Alright. And there's different ways of stating my answer. One way to state my answer, I'm just going to put it up high, the x cubed minus 2x squared plus 6x minus 12 divided by x minus 1 is equal to, now my answer is x squared minus x plus 5, and then with my remainder of, so minus 17 over x minus 1. So that's the one way to do this. The other one is, now if you imagine if I multiply both sides by x minus 1, so I just get this by itself here, I will get x minus 1 multiplied by x squared minus x plus 5 minus 17. Okay, so this is the first way of saying the answer. This is a second way of doing the answer. Alright, now that might seem a little laborious, and some of you might be saying, oh boy, I wish there was sort of a quicker way because there's so much writing involved. Well, that's what synthetic division is. Synthetic division is kind of long division with as many shortcuts as humanly possible. Now we might look at these 8 steps and you go, oh my goodness, there's 8 steps to memorize. But it's like if you were to actually break down all the things we did in long division, there would be at least 8 steps as well. So we'll try these a few times, but I don't think it'll take too long before it'll just kind of make sense. So this type of division uses only the coefficients of each equation. So we're not going to be writing down x and x squared and all that kind of stuff. We're going to be taking care of those things by just which column all the numbers are in. So you'll notice when we did this work, this is where all the x squares are, or x cubes are. This is where all the x squares are. This is where all the x's, and these are all numbers. So really it was kind of extra effort of writing that all the time. So this is a system of sort of taking care of that part. Now, in the beginning of this lesson, I mentioned about this x minus a idea. So if we're thinking about what is a, if we're dividing by x minus a, so a is going to be the opposite of whatever that is. So in this case, we're going to say we're going to be using an a value of -2. The way that this in step explains this is to use the divisor to solve for x. So if you've got x plus 2, say x is equal to -2. So really what they're doing is they're saying equate that to 0 and get a -2. The textbook uses this language of an a value being -2. So what we're going to be doing is we're going to, if we see x plus 2 is the binomial, which is the divisor, in synthetic division we're going to be using a -2, right? If, for example, it was dividing by x minus 2, then my a would be equal to 2. So it's the opposite of whatever that negative, whatever this is here next to x in our binomial. And then we'll write out only the coefficients. Instead of reading it all, let's just practice it once. Okay, so first of all in this question here, I guess I have to ask, what would be my a value? If it's dividing by x minus 1, if it's dividing by x minus 1, then a is going to be equal to 1, right? So think about this x minus a form, right? So a is going to be equal to 1. So now I need to write this out again, but all I need to do is write the coefficients and not the x part. So instead of writing x cubed, I can just write, and maybe I'll write it down over here, so I'll just kind of think down over here, I'll just write a 1. Instead of writing minus 2x squared, I'll just write a minus 2. Instead of writing a plus 6x, I'll just write a 6. Instead of a minus 12, well, I guess I do, I write minus 12. Now it's time for the second part where they talk about this make an L shape. So the L shape is the way we do division, right? So I'm going to make this L shape. This is how it looks. Just across like that. You'll notice I'm leaving space underneath those numbers. And the a value, which is 1, goes over here. Okay, so it looks a little bit different than our other form of long division. So now the rule is that when I'm dropping things down, I add. So I'm going to go 1 plus, well, there's nothing there, so in the first part it's just really take this number and write it over here. Now, whenever I go from this spot up to this spot over here, I'm going to be multiplying by my a value. So in this case, each time I'll be multiplying times 1. So I'll say 1 times 1 is 1. And now I add these two together. So I go -2 plus 1 is -1. And now again, when I go up this way, I'm going to be multiplying times 1. So whenever I'm doing that, going to the next column, I go up and I fill this out and I go -1 times this 1 over here is going to be equal to -1. And now I add these again. 6 and a -1 added together is 5. And then I go up over here again. And really, I'm only drawing those little arrows just for this example. Normally, I don't do that. 5 times 1 is 5. And now -12 plus 5 is -7. Now, you might say, where's the answer? And it'd be a good criticism. So usually what I do is put a little box around that. This last bit here, this is my remainder. And this over here is my answer. That's my quotient. It's a little bit hard to tell. So this is my constant term, so I'll say a plus there. This would be my linear term, so I'm just putting it in descending order. So this is x squared minus x plus 5. So if I'm going to write out my answer here, when I write this answer here, it's going to be, well, I'll get a good pen here. I was dividing by x minus 1, so it's going to be x minus 1 times, well, what was my quotient? X squared minus x plus 5. And then my remainder minus 7. Okay, and my restriction, doesn't have it in here, but my restriction is that x cannot be equal to 1. All right, I have an example here to do. Now in this example, it is in descending order already. So I've got my x cubed, my x squared, but I don't have any x term. So I have to be careful here. So I'm going to rewrite this. I'm going to write 2x cubed plus 5x squared plus 0x plus 9. Okay, and now I'm going to be dividing by x plus 3. So when I'm thinking about that x plus 3 here, I'll think, oh, okay, that means that my a value is going to be equal to -3. Okay, so this 0 part, let me see where that is in the instructions, in the steps. It says, if any, oh yeah, write only the coefficients of the equation. If any are missing, fill in their spot with a 0. Make an L shape with the value of x outside. Okay, so that's what we've done here. So we've put that 0 in there, and now I'll write it without the coefficients. So I'll say this is just going to be 2, 5, 0, and 9. Make my L shape, and I've got an a value which is -3, and now I'm ready to start. So I'll say I'll bring down the 2. 2 times -3 is -6. Now my 5 minus 6 is -1. Now I multiply by -3 over here, so I get 3. 0 and 3 added together are 3. -3 times 3 is -9. 9 and -9 is 0. Okay, so this here, it kind of works out nicely, doesn't it? This is my remainder of 0. And this will be my constant term. This will be my x, and this will be my x squared. So my answer at the end, I have to state my answer. Boy, they give me so much space here. So my answer will be, well, let's put it in both ways. We can say 2x cubed plus 5x squared plus 9 divided by x plus 3 is equal to 2x squared minus x plus 3, or the other way to write it was 2x cubed plus 5x squared plus 9 is equal to x plus 3 times 2x squared minus x plus 3. Okay, so both ways are acceptable. All right. I think I'm going to give you this one here to do as a your turn. So try this one on your own. Pause it, try it on your own, and then I'm going to come back and write it out for you. All right, here's the answer for this. There was no trickiness. This was all in nicely descending order, and there were no gaps, so I didn't have to insert any zeros. When I finished the synthetic division, I got a 0 at the end. I got a remainder of 0, which is kind of cool. And so I wrote it out in this form. X cubed minus 7x, all that big polynomial divided by your divisor, and here is your quotient. And of course, because your remainder was 0, I didn't really have to say plus 0 for the remainder. So I put it in that form. You could have put it in the other form as well, which is just fine. I'm going to stop now, and I'll take care of the remainder theorem in another video. Thank you.